Hello, good morning, students. Today I am going to give you two equations. One is plane in normal form, equation of a plane in normal form. Another is equation of a plane passing through a point and perpendicular to a given vector. The first one, if n cap is a unit vector normal to a given plane directed from the origin to the plane, and p is the length of the perpendicular drawn from the origin to the plane, then the vector equation of the plane is r dot n cap equal to p. So what we have? We have a plane. O is origin, n cap is unit vector directed from origin to the plane, and on is p. So on vector will be p n cap. Now you consider p any point on the plane and you join it, then this np and on vector will be perpendicular. Therefore np vector perpendicular to n cap, so their dot product will be 0 because they are perpendicular. np vector is op vector minus on vector dot n cap equal to 0. op is r, position vector of any point p denoted by r. on vector is p n cap. p is the length of the perpendicular. n cap is unit vector directed from origin to the plane. Now if we take dot product, then we will get r dot n minus p n cap dot n cap equal to 0. r dot n cap p n cap dot n cap is 1 unit vector, so there will be 1. So this implies r dot n cap is equal to p. So this is the vector equation of the plane, where n cap is a unit vector normal to plane, where n cap is a unit vector normal to plane directed from origin. P is the length of the perpendicular from origin to the plane. R is position vector of any point P on the plane. So this is the vector equation. Okay. Next equation. Equation of a plane perpendicular to a given vector and passing through a given point. So you draw a plane. The plane passes through a given point. This is perpendicular given vector. This is normal vector n, suppose. The plane passes through this point A, suppose. Position vector of the point A is vector A. If we take any point P on the plane whose position vector is R, now if you join A and P, then this normal vector will be perpendicular to AP. The plane passes through a fixed point A and perpendicular to a given vector n. P is any point. Then this n vector, normal vector, will be perpendicular to AP. Therefore AP is perpendicular to vector n. So their dot product will be 0. So AP dot n will be 0. AP is position vector of P minus position vector of O, position vector of the point A dot n equal to 0. So this implies OP is R, OA is A dot N equal to 0. So this is the vector equation of the plane passing through a point and perpendicular to a given vector N. Okay, this is vector equation of the plane passing through a point A whose position vector is A and perpendicular to a given vector N bar, perpendicular to a given vector N is R minus A dot N equal to 0. Now if we take an example, suppose the plane passes through a point 1, 2, 3 and perpendicular to vector N. Vector N, suppose 3i minus 4j plus 5k. Then what will be the equation of this plane? The equation of the plane will be R minus A dot N equal to 0. R you keep same, minus A is position vector of this point, so it will be 1i plus 2j plus 3k dot N equal to 0. So this implies R dot N minus I plus 2j plus 3k dot N is equal to 0. So it will be R dot N is 3i minus 4j plus 5k minus I plus 2j plus 3k dot N vector 3i minus 4j plus 5k equal to 0. So we will get R dot 3i minus 4j plus 5k. You take dot product, minus 1 into 3 is 3, minus 2 into minus 4 is minus 8, 3 into 5, 15 equal to 0. So you simplify this number, you will get the equation. So it will be R dot 3i minus 4j plus 5k. 18 minus 8 is 10, so it will be minus 10 equal to 0. So this is the equation of the plane. Okay, this is the standard formula.